can work for you too. I am really pushing hard, and the next version of Gradecraft will support this explicitly for a pointsless system, where it is all about learning outcomes and competencies. So we are right now working with the dental school, the business school, and the medical school for a completely outcomes-oriented tool that actually crosses courses. It's about your program. What are the skills, competencies, and attitudes that are involved with being a physician? And then the courses are some of the places where you get those. And then there are non-course kinds of experiences where you get some of those things. And Gradecraft 2, or I hope is really version 1, will help you and your mentors track your progress across that space. And then within a course, the course itself may touch on some of those outcomes. And you'll be able to see, instead of points, it would be which of the learning outcomes are you achieving. We don't have a representation of that yet that I can share. Very early going with that. In some ways, I should say that part of what our work here is doing is trying to sow the seeds for a complete rethinking of what undergraduate education is too. So this work is hand in hand. We were funded at one point by the Learning Analytics Task Force. And this is a part of the work going on that you may have heard about with the Digital Innovation Greenhouse. And we're also, part of what we're doing this year in the DEI, the Office of Digital Education and Innovation, is starting to brainstorm a model for something that, like the honors program, created a special space inside LS&A for particularly high achieving students. We're trying to think of what would a parallel course be like, what would a parallel institution be like within the institution for very open-ended learning that was outcomes-driven, maybe uses micro-credentials or badges, allowed students to explore broadly across university, across content areas, and Gradecraft is helping us think about that. Other questions? Teresa?
Yeah, I do have a question.
Question for me?
When it comes to, so one of the ways that you were looking at an option for homework was blogging. And I was wondering, so when the student, like if you have something that's a bit more of subjective in terms of the grading, how are points assigned to that in comparison to like the something that's less subjective?
So one thing that we support here is rubrics. So you would want to have, I'm on Gradecraft, there we go. So hopefully this demo class has a rubric in it, and I'll switch to my own. But so here's a rubric that lays out different categories that I want to see represented in this assignment, and then has descriptions of what the categories are like. Does anyone here use SpeedGrader and Canvas? Canvas does this very well, actually, where to grade, all you have to do is click on one of these as an instructor, and then it assigns those points that are assigned at that level. And in my rubrics, I'm not sure if this one represents it, sort of meets expectations is, again, at like roughly 80% of points. And then I often have, here it's called full credit, but in my classes I often say like above and beyond the expectations. I try not to use the letter grades because that again drives the students crazy. What do you mean I got to be and I met your expectations? So I say, well, you met my expectations, full stop. We're overcoming years of training that they've had about what success looks like.
So if the student chooses to do blogs and other students don't, the instructor is really just grading those particular blogs and entering, and then that gets calculated in. But,
yeah.
Okay.
And you can, as an instructor, choose that some assignments may have deadlines. I mean, so I gate a lot of assignments. So there's certain things that you can only do up until the second week of the term, and other things that you can't start doing until the 8th week of the term. And certain things you can't do unless you've done something else to a certain level of success first. That would be the unlock model. And that's a way, and so Mika, for instance, lets you do blogs, but only after you have done some other writing to show that you're ready to do blogs, because his blogs are available to the public. And so he's got a gating function for that. I have an activity where if you don't reach a certain level of performance, I've got a poster you can do twice to show your progress on some other project in class. But you can only do it, unless you do a certain level of quality on the first poster, you can't do the second. So there's this notion of you can't. That's the other thing, by the way, that happens a lot in these grading systems is if you don't, the challenge of what to assign value to and how to assign value is challenging because you want to design your system such that a student can't do a lot of low-level stuff and do well in the class in the end. they have to do well on high-level stuff, which is part of the reason we have tens of thousands of points, so that you can have things like attendance you think are important, worth something meaningful, but not enough that it's going to actually get them a grade in the end, or make a difference in a grade. I mean, for me, in my system, attendance, as in probably I would wager most of your systems, class participation, may be the difference between an A- and an A, or B+ and an A-, but it's not enough to just do that kind of stuff and get any meaningful grade out of the class.
So I have a more personal question. So if I were to take, so if I have animations that are in conflict, and one of the things that we're struggling with is how to make this just an online sort of exercise. So one thing would be to have students construct their pictures and then to kind of blog about what they've designed. And so I'm wondering what suggestions you would have for gamifying that environment.
Well, one challenge you're going to have if you have big classes is assessing a lot of things. So I wouldn't actually necessarily recommend people with more than 50 students in their class think about blogging. Mika does it he's got a lot of GSI support. You might want to look in, so CS, for instance, has a lot of auto-grading. So people submit code, and the code gets graded by an algorithm. That may be a way for them to deal with this, right? You get to try a lot of different pieces of code, a lot of different ways. So you can also think of peer grading as, I think, going to be one way out of the grading bottleneck we're in. So if you submit a model or interpretation, then you unlock the ability or the responsibility to grade 2 others, and only after you graded 2 others does yours become available for grading. There are different models for supporting this that have been worked out in other contexts, but the notion, I think peer grading could become really important in this approach because we are the bottleneck in terms of our time. And I often describe my own grading work. I used to lose a couple of weekends during the semester just grading, midterm, final. Whenever I had a paper due, I would lose multiple weekends and take me a while to get feedback. Now my grading is more like a constant low fever, where I'm grading a little bit every week, all the time. But I don't lose weekends anymore. It's just, every week I look and see what students have done and get the feedback on that. Or I have my GSI responsible for tracking that with me too. And we've set the system up in a way that there are tools. I've only shown you the student side. The instructor side has more tools for observing what people are doing. So there are leaderboards for you to sort of zero in on the students who are needing help. There are ways to flag students for follow-up later. You can also, if you're an instructor with multiple GSIs, you can use that to monitor compare your GSI's relative grading progress and output. This is another way. So, what if there's, it's easy, you'll hear it from your students if one GSI is grading much harder than the others. But with this system, you can tell very easily what's going on very early and intervening. Other questions?
I had a question for Risa, actually.
Yeah.
One of the things I find fascinating in thinking about things like animations, things that are like very interactive publishing, is, and you actually took me back to the dark ages of the internet when you said 1996.
Yeah.
And think about how far we've come, but on the other hand, it still is, and you specifically mentioned collaborating with designers. I was curious about that process, because frankly that terrifies me, to have to put so much like trust or establish a relationship with somebody who's completely outside of your field. Could you talk about how you identify those collaborations and how they work in your experience?
Yeah, so, So at first when I started out in as a professor at San Jose State and I was trying to just design, like I said, I was really concerned about the acceptance from the professionals in the field. And so that's why I set out to study them. And I had an advisory panel that looked at some of the animations that I designed. And the problem with the advisory panel that I selected is that, well, they were pretty critical, but they, it was still kind of like we're all kind of in the same, they had similar perspectives. And so I don't think it, gave me like the sense for how a range of instructors might view those tools. And the other part that's problematic is that you don't know the abilities of the instructors, because you still have a lot of instructors that are not willing to take the time. And I have to be honest in that when I teach, I don't often show a full animation. I'll usually show a still image from it, and I want the students to actually study it more outside. So you've got all of these kind of variables that come into play. So to identify people to collaborate most recently, I chose to work with a professor in Turkey who we both were trained at the same in the same ChemEd doctorate program. And so we both come at studying animations from the same kind of viewpoint. But she's designed different animations that I've designed, so we have unique perspectives on how to approach the design of the animations. And we're both pretty, like, we trust. Like, I think it's important to have that trust, and you just learn that by sludging along and trying out different collaborations and seeing how it works. But so after I worked with her, you start to look for people in the field that are also interested in that area. And so Roy Tasker is one. Roy is somebody who has a completely different perspective than I have when it comes to animations. He wants to do more upfront training so that when the student goes and sees this really complicated animation, they know how to navigate. And I come from more I like to just toss them in, let them play with it, and see what they're coming away from it with. And so we conflict a little bit in that, but he brings the perspective that's a bit more technical. Then I tend to go more simplistic, and so I think again we have like different sort of philosophies on how to animate, and it's important when you're designing the tools to make sure that you bring in all of those perspectives. But ultimately, you have to have a product that you believe in and that makes you happy. And then you have to hope that, you want to see that students are learning from it too, so you have to have that evidence, we can imagine. So that's where I've got that evidence, but now it's just a matter of making the tools less clunky and a bit more easy to take to the bigger masses of students. So that, again, there's like all these like little tiny problems, and then you have like the philosophical like viewpoint. So you have to take all of that into consideration. Ultimately, I think it comes down to how well you just get along with people and are willing to, like, you have to trust, you have to be okay with the criticism that you're going to get from them and want it. And then you have to be like, equally, you have to have their trust as well. So it's kind of, yeah, it's an interesting world. I've run into situations where I've had people that, for whatever reason, it's just, you're kind of miserable, and you just kind of identify that pretty fast, and then you distance, and then go in the direction that, if you can. I don't know if that helps. That's how I do it.
One question for you, actually. So it's more like back in the days, probably I'm talking about 10, 15 years ago, people are really stressed on hands-on learning, like visualization to actual experiment.
Right.
And then I'm just wondering, how do you tie that, the hands-on with the animation, or do you do them parallel, or you kind of want to like substitute it in the end, and then also the last part is, what is the order, if you think about integrating the animation with the hands-on experiment, what is the order you're going to show the student, the animation first or hands-on work first?
Well, I think you could go either way. But I personally like to show them, so I think that there's different philosophies on how to even construct like textbooks, and right now you're seeing like the Adams First approach is kind of big right now. I've heard interesting arguments to the Adams First perspective, which is that you're starting with the abstract, and that perspective looks to explain or to give the answer, to not let the student really struggle. I think it's trying to say, okay, here's the atom, and now let's understand how it reacts. And so you're taking it more from, we know the answers, we're going to teach them to you. But when it comes to, if you think about how, I guess, like chemistry, like how we've learned and chemistry as a field has developed, it started from that experimental stage. Like here's physical evidence. What do we think is happening? And it used to be that we just sort of philosophized about like what was happening, but now we've got tools that help us create images. We've got better instruments that help us even give more insight into it. So I kind of actually have been going more toward that route, where I look at how to take an experiment and I try to make it a little bit more complex than just like trying to bring more variables in. How do I explain that? Like in the case of a redox reaction, the students have also at San Jose State have had labs where they test the conductivity of solutions. And so I recognized I could actually bring conductivity into the redox study, because if you really think of what's attracting the silver, like the ions that are in solution to become reduced, it's a difference in electrical potential that draws them to that metal surface in a single replacement reaction. And that's similar to conductivity, where you have a battery powered like difference in potential that causes ions to move in the field. So I brought that piece in primarily to help students to key into that as, how do we know what's going on in the solution? How does conductivity help us understand that? So that's one little piece of evidence. So trying to create a bit more complexity in terms of just the reaction environment and the tools that we look at, and then specifically using kind of a logic for how could you reason from that macroscopic evidence to then animate these like submicroscopic events. It's really important that you can tie into the evidence and use it to justify or support why you view one way or another. And what's interesting is that sometimes it backfires on you in the sense that, so for example, with the task for animation, he really was focused on a couple of things. One, he wanted to show how important water was in this process and how water is surrounding the silver ion as it is attracted toward the copper surface. But then he also wanted to recognize that as that copper ion forms, that water is actively involved in pulling it into solution to kind of show that the purpose of the water. And the thing is that when students were looking at the experimental evidence, I had one student who said, well, actually more than one, but they were looking at the conductivity test, and they're like, well, I know water doesn't conduct. I know water can't be involved because water doesn't conduct. And that animation shows that water is involved, so I know that that can't be right. That other animation where water isn't involved has to be the one. And when I first saw that, you kind of that cringe, like, oh, that's kind of backfired. I didn't want him to go there. But now when I'm actually, this is where I started to kind of buy into this whole idea that we can't force or teaching on them in the sense of correcting a misconception. And actually the reasoning that they're using to come to that determination, that reasoning strategy is actually really good. Good scientists have made mistakes in that manner. I mean, look at Niels Bohr. Look at the whole history of the atom and how that came into being. There were so many mistakes that were made along the way, and then someone makes a little bit of progress and they go, oh wait, that wasn't quite right. What they were thinking there didn't quite work. So I'm actually starting to feel like it's more about the strategy, giving them time to work with it. So I'm less worried about them coming away with wrong ideas, because I don't think that those will persist. I think that if we can teach them the strategies, that'll actually help them when they go out into the world and actually have to vote on an issue. They're going to think more along, I mean, they still can make mistakes, but it's like they're going to draw on the evidence to support why they make a decision. That's what I really want. So I guess ultimately I think you have to have kind of that belief structure in place of what you want to happen, and then you can work with that. But to counter that, I can definitely see you could show an animation first, and you could actually show both animations, a correct and a wrong one, and now say, all right, here's two possible scenarios for how an event happens. But now we're going to actually look at the reaction event and see if we can reason back. So you could probably, I don't think it would matter as much the order, but it'd be interesting to look at. Again, I feel like when I design this stuff, I feel like it's such a scrambled mess for how I'm putting it together. I wonder how, if you're, from your perspective, you must think, wow, that's just, what a mess. But it ends up being kind of neat and tidy in the end. It's just kind of, it is messy. Learning is really messy. And learning is, if you really examine how you're thinking about things, your brain is taking you in a lot of different directions. And so how do we capitalize on that? That's what I guess I want my students to do.
For either of you guys, what kind of feedback do you actually get from students when you use this type of not cookie cutter curriculum? Do you get good feedback, bad feedback, all of it?
Do you mean what shows up on Rate My Professor or what?
Sure, yeah. Do students enjoy this?
So when I did my research in the experimental or the research setting, where they come in my office and I'm having them look at the experimental evidence and then watch the animations, I asked them, have you done anything like this before? And they'll say no. but it's really, they'll say that, like what you said about the gaming and how when they don't have the answer, but they have to reason about it, they actually kind of like it. Like a number of the students said it was kind of fun to try to figure it out, which animation is right or not, but they want to know the answer. And maybe it's that you know, as long as they want to learn the answer, maybe we have them. But I'm kind of one of those that I'm more inclined to not give them the answer, like, you know, so you'll just have to go away, just wondering. But for the most part, I've heard some positive things in the experimental setting. In the actual classroom environment where I've tried these things, I've gotten, I mean, there's still the struggle. They're pre-meds, a lot of them. They don't like it if third grade is, you know, left to you know, to anybody else. They want points and they're very, so it's a little bit harder.
So we gather data on this as part of our work, and in gameful classrooms, students generally enjoy that they rate the classes higher in these environments because they perceive them as being fairer, because everybody can accomplish what they set as their goal, and then they're supported to it when it's executed, you know, in a productive way. So we typically have instructors getting very positive feedback from students about this. What's interesting is among the 19 classes that used this last year, that represents about 15 instructors. I would say 11 of them had something go disastrously wrong at some point. You know, something totally that they didn't foresee, that we didn't necessarily foresee or at least prepare them for well enough. But they all signed up to do it again because they saw some spark in how their students were responding that really was appealing, and they said, I could. And I often like to, my own experience in education in general is that most things take about 3 trials to get about right. You know, the first time you're stumbling, the second time you're overcompensating, and the third time you start to own it a bit and really customize it to be your own thing. The students who initially react poorly to this are the super high achievers who can't understand why you're changing the system which they have mastered, and the super low achievers who need to really be directed, like, okay, no, really, don't wait for the midterm to start paying attention. There's something is different here. If you don't start right away, you're going to fall behind and not be able to recover. But by the end of the term, everybody generally is on board and thinks, wow, why aren't more of my classes like this, where I can basically choose. So I should say, I have a lot of students in my class get A+. And that is a turnoff in some departments. Some people feel like his class must be too easy. But in my class, I set an A at 1 million. There are 1.8 million points available in my class. And the students who are getting A+ have to earn 1.3 million. So they are earning far more points than they need. They're working their butts off. And they're second semester seniors frequently because you can't get into my class. It's so popular unless you get to register early. So that I get athletes and second semester seniors. That's my population. And after that, it's like half engineers and half like people from LS&A and business. So it's a very weird population. But the students who see, oh, I can get it, it's sort of like Sir Edmund Hillary. Why did you climb that mountain? Because it was there. Like, you showed me how I could accomplish that, and so I did. And it's quite remarkable how hard they'll work to get there and how pleased I am with how much I think they've learned in that process.
I'm curious to ask a follow-up question on that topic where you mentioned primarily senior enrollment. Are there any courses currently using this implementation that are primarily freshmen or young students? And is there a comparison or a